Welcome to the lecture series of ultraviolet spectroscopy. So in this last series of this ultraviolet spectroscopy, we are going to discuss about applications of this ultraviolet spectroscopy. So from the beginning, we were discussing about what is the light or the property of light, what happens when the light interacts with the substance, matter, or atoms or molecules, and how the absorption and the transmission takes place with the help of Beer-Lambert's law, and what are the excitation happens in a molecule, that is electronic excitation levels. And we discussed about instrumentations, light source, monochromators, dispersing materials, and Hoover, that is sample containers, detectors, and amplifiers, recorders, etc. Now, in the application part, just you observe these two spectrums. The top one is a standard PCM, that is paracetamol, and the bottom one is a paracetamol with impurity. You see, after 1000 nanometers, centimeter inverse wavelength, near to 1000 or after 1000, in the pure paracetamol, there is almost a straight line, but in impurity, there is several absorption peaks available. So I'm starting with a typical example that the impurity of a substance can be identified when compared with the pure one with the help of the ultraviolet spectrum. That means we can compare the standard with an unstandard to identify something is observed there. Yes, the ultraviolet spectroscopy has some popular applications. Why? Because this is a non-destructive one. The sample cannot be destructed. Once the sample used, the sample can be reused again and again. Even for some other purpose, the sample is not evaporated. The sample is not going to get decomposed, and it is a non-destructive one. And that means it will not give any alteration or changes in the sample which we are using. The measurement can be performed quickly. Within 5 minutes, we can finish the measurements. Yes, little training is no skill is required for this. Little training is enough to handle the instrument. And a very minimal processing in the data analysis. Instrument is not a costly one, so even many industries or many institutes can avail this. Some important application is DNA and RNA analysis. The ultraviolet spectroscopy can deal with the purity of nucleic acid. Just now we started with the purity of paracetamol medicine. The quick verification of the concentration and the purity of DNA, RNA can be done in this. This is essential before the preparation of DNA, RNA for a sequencing. In 260 nanometer or 280 nanometer, absorption ratio is essential to display the contamination in nucleic acid by proteins. So in pure DNA, this is 1.8, and that is pure RNA, it is 2. But if some absorption has been present in this ratio, so we can understand there is an impurity present in this RNA and DNA. Pharmaceutical analysis. In pharmaceutical analysis, as I explained to you before, the overlap of absorption peak in UV spectrum can be used to find out the pharmaceutical compounds using mathematical derivations. For example, an antibiotic, chlorotetracycline, and an anesthetic, benzocaine, are identified simultaneously in the veterinary powder formulation using the first mathematical derivative. By calibration function of each compound, simultaneously quantification was done on micrograms per milliliter concentration. The bacterial culture. UV visible spectroscopy is essential in biomass growth curve studies. The routine OD measurements, that is oxygen demand measurements, are taken at 600 nanometers for estimation of a cell concentration and the growth track. 600 nanometers is chosen due to the optical properties of the media in which the bacteria is growing and to avoid damage to the cells when there is need for a continuous experimentation. Beverage analysis. So, in beverages, identification of particular components of the drink. So, we can find the contamination or we can find the sugar level. We can find any additives are present in that. Quantification of caffeine content can also be studied, whether it is in the prescribed limit. Identification of anthocyanin in blueberries, blackberries, raspberries, and cherries for quality control in wine can also be easily studied. So, like this, we have a lot of applications in ultraviolet spectrum because it is due to the main advantage that it is non-destructive and easy to analyze. Thank you. So, in this lecture series, we have started from the light and deeply discussing about the principles, instrumentation, and application of ultraviolet spectrum. So, thank you.